Video, we're going to look at the reaction of bromide salts with concentrated sulfuric acid. The first reaction is similar to the reactions that we've seen for chloride reacting with concentrated acid. So if we take a bromide salt and sulfuric acid, we end up making a hydrogen sulfate, so potassium hydrogen sulfate salt, and a gas that is hydrogen bromide. So we would observe steamy white fumes, and that's from the hydrogen bromide gas. And as nothing or no element has changed oxidation state, this is not a redox reaction, so the sulfuric acid is behaving like an acid. If we think about the redox reactions, so the bromide ion is going to be oxidized to bromine. So we would get an oxidation product or an oxidation observation. And that would be orange fumes caused by bromine. So the observation would be orange fumes. And that's due to the oxidation product. The sulfuric acid would be reduced to sulfur dioxide, so we'd get a reduction product or observation due to the reduction part of the reaction that is happening, and we would observe a choking acidic gas, and that would be due to the sulfur dioxide gas being produced. So we've got an equation for the oxidation part of the reaction. To write an equation for the reduction, we need to use some of our redox rules, and we need to know that the change in oxidation state from the sulfur has gone from +6 to +4. So we need 2 electrons on this side. We need 2 waters on this side to balance out the oxygens, so we've got 4 oxygens on each side, and we need 2 more hydrogen ions on the left hand side, so we've got the right number of hydrogen ions on each side. And if we cross out the oxidation numbers and add up the charges on each side, you can see that those charges equal each other. So we've got a reduction half equation and an oxidation half equation. If we combine both of them together, if we look at how many electrons are produced in the top one and how many are needed in the bottom one, we've got the same number, so we can simply just combine them both together, cancelling out the electrons because they're going to appear on both sides, and we end up with an overall redox equation showing both the oxidation and reduction process together. And again, I can check, do the charges add up on both sides? And if they do, it means that equation is correct. So because the bromide ion reduces the sulfuric acid, we can think of the bromide ion being a reducing agent. So the role of the bromide ion is as a reducing agent, and the sulfuric acid is accepting electrons, so we can call the sulfuric acid an oxidizing agent.